Okay, welcome back. So let's start by talking about Taylor series. What is it exactly? Which I thought I knew, but then I started teaching it, and then I realized I don't really know it. But I'll share with you what I do know. Okay, so let's suppose that y equals f of x has a power series representation about x equals a. All right, so that means, again, that we can write or we can express f of x equals c0 plus c1 x minus a plus c2 x minus a squared, so on and so forth. Let me write that in terms of the series. Now I'm using c's now. Oh well, because I want to do it about x equals a. All right. So now a couple of things that we sort of can learn from this, or just from this, just from assuming this. Okay. First, well, we know f of a equals c0. Okay. We could even take f prime of a. Okay, because f prime, let me do f prime of x first. F prime of x, well, we can do the derivative term by term, is c1 plus 2c2 x minus a plus 3c3 x minus a squared. Let's do one more. 4c4 x minus a cubed, so on and so forth. All I'm doing is taking the derivative of the terms that I haven't written but are there. As we've already seen a couple of times now, n goes from 0 to infinity, n plus 1, c sub n plus 1, x minus a to the n, right? Again, you put the n in front, and then you do that shift. We've done it a couple of times now, okay? God damn it, let me just do it. F prime, sorry for the swearing. It will happen again, so I guess I'm not sorry. Okay, so some n goes from 0 to infinity, n c sub n x minus a to the n minus 1. Remember, I'm saying that at n equals 0, this is 0, so I need to shift it. I also don't like this n minus 1. Okay? Now, what is f prime of 0? I'm sorry, f prime of a. F prime of a is just going to be, well, I'm just going to take the n equals 0 term. So it's going to be 1 times c sub 1. All right, let's do another. I want to get the general form for the, let's say, kth derivative. Okay, so let's do f double prime. F double prime of x equals, differentiating term by term, n times n plus 1, c sub n plus 1, x minus a to the n minus 1. Again, we're going to do this same game of shifting indices from 0 to infinity. I don't like that n equals 0. I don't like that n minus 1. So I'm going to shift it out. N plus 1, n plus 2, c sub n plus 2, x minus a to the n. So what is f double prime of 0? I'm sorry, of a. F double prime of a is going to be 1 times 2 times c sub 2, right? Every other term becomes 0. Okay, I can continue in this way. And so the kth derivative at a is going to be, you guessed it, k factorial c sub k. We actually reverse it. C sub k is the kth derivative of a over k factorial. And this allows us to write our Taylor series. So our Taylor series is going to be just the power series, and we can find the coefficients by taking derivatives of f. Okay? So f of x equals the sum, let me write it, n goes from 0 to infinity. I have to change the k's here to n's. So it's going to be the nth derivative taken at a over n factorial x minus a to the n. Okay, so this is the definition of the Taylor series. Okay, now we can take it up to a certain point. So what we can do is we can take the sum, n goes from 0 to, let's say, some capital N, f sub n of a over n factorial x minus a to the n, plus we can take the tail. Let me write it down again. And here, all I'm going to do here is I'm going to change this to n plus 1. So what I'm doing, I'm adding up the first, let's say, 10 terms. 10 is just an arbitrary number, some number of terms. And then I take the rest and I sort of consider that as a remainder. Okay? So this is called the Taylor polynomial of degree n plus the remainder term of degree n. Okay. All right, I'll see you in the next video.